You know that simple glass of milk you might have in your fridge? Well, it's hiding a pretty big secret. Turns out it's a total masterpiece of chemical and biological engineering. And today, we're going to take it apart piece by piece to see what makes it tick.
I mean, it seems so simple, right? It's just white. But it's actually this incredibly complex system of fat, proteins, sugars, and minerals, all perfectly balanced and designed by nature. So, what is really inside? Let's dive in and break it down.
Okay, before we can really deconstruct this, we got to get a couple of key terms straight. First up, if you were to remove all the fat globules from milk, the liquid that's left over is what scientists call plasma. You and I, we just call it skim milk.
Yeah, what if you take that plasma, that skim milk, and go one step further? You take out the main protein structures, which are called casein. The liquid you're left with now, that's called serum. And you probably know this stuff as whey. Yep, the same stuff in all those protein powders. So just keep plasma and serum in mind as we go.
All right, we've got our terms down. Now for the fun part, the deconstruction. We're going to look at the three main building blocks of milk. First the fat, then the proteins, and finally, all the sugars and minerals that make it complete. So first up is the fat. Milk fat is what gives milk that rich flavor and creamy texture we all know. But what's really fascinating are its microscopic properties. That's the secret sauce that lets us make some of our absolute favorite foods.
At its core, milk is what's called an emulsion. That's just a fancy way of saying you've got tiny little droplets of one liquid, in this case fat, just hanging out, suspended in another liquid, which is mostly water. These fat globules, they make up about 3.5% of whole cow's milk, and get this, contain over 400 different kinds of fatty acids. They're also the reason milk is white. They scatter the light that hits them.
But here is where the real magic starts. Right when milk comes from the cow, it's warm. It's at body temperature. And that means all of that fat is completely liquid. Just imagine these tiny, melted droplets of oil floating around in the water.
But as soon as that milk starts to cool down, a huge physical transformation begins. Some of those hundreds of different fats, the ones with higher melting points, they start to solidify. They actually form these microscopic needle-like crystals inside those liquid fat globules. Now, this might sound like a tiny detail, but trust me, it is absolutely crucial.
So why is this so important? Well, this crystallization process, it is the entire secret behind whipped cream, butter, and ice cream. No joke. Those tiny solid fat crystals are what allow the fat globules to poke each other, stick together, and build stable structures. Without them, you literally could not whip cream or churn butter. That simple act of cooling changes everything.
Okay, next up, the protein powerhouses. You see, milk has two major families of protein. And while they're both super important, they're designed to do completely different jobs. So those two protein families are casein and whey. You can think of casein as the structural workhorse. It's a solid suspended in the milk, just waiting to clump together to form the curds that we use to make cheese. Whey, on the other hand, is totally soluble. It just dissolves in the liquid part of milk, which is why it's the liquid left behind after you've made cheese.
And, this isn't an even split. It's not even close. Casein is the undisputed king of milk protein. It makes up a whopping 83% of the total protein in milk. Whey is important for sure, but it's definitely the minority shareholder here.
So here's a question. If casein isn't soluble, how does so much of it stay suspended in the milk without just sinking to the bottom? The answer is one of nature's most brilliant little pieces of engineering, something called the casein micelle. It's basically a microscopic container that holds the whole system together.
So how's it built? Well, you start with hundreds of these smaller protein clusters called submicelles. Then the real genius kicks in. The micelle uses calcium phosphate, that's just calcium and phosphorus from the milk, and it acts like a natural, totally edible superglue. These little bridges bind all the submicelles together into one big, stable, spherical particle that can just float around in the milk forever. It's how milk manages to carry so much protein and all that bone-building calcium. All right, let's move to our final section. We're going to talk about the stuff that gives milk its sweetness and a whole lot of its nutritional power. The lactose, the minerals, and the vitamins that are all dissolved in the whey. That slight sweetness you taste in milk, that comes from its main carbohydrate, lactose, also known as milk sugar. It makes up about 5% of milk's weight. But don't let the name sugar fool you. This isn't just any old sugar. This is a smart sugar, and it has a very specific job to do. Lactose is a truly functional sugar. For starters, it's intentionally less sweet than regular table sugar.
which actually encourages infants to drink more of it. It also helps create a gut environment that lets the body absorb crucial minerals like calcium and phosphorus, all while stopping harmful bacteria from growing. And as a bonus, when it gets broken down, it provides something called galactose, which is a key building block for developing nerve tissue. It's pretty incredible, right?
And of course, we can't forget the minerals themselves. We already saw how calcium and phosphorus act as the superglue for those casein micelles, but their main job is to provide the raw materials your body needs to build and maintain strong bones and teeth. You could say milk is nature's original, and maybe most efficient, delivery system for these two essential minerals.
So the next time you look at a glass of milk, you're not just seeing a simple drink. You're seeing a colloidal suspension, an emulsion, and a solution all rolled into one. You're basically looking at a masterclass in food chemistry. Which really makes you wonder, what other foods are out there hiding a whole secret scientific world right under our noses?